we have Mr. Dipankar Ghosh, who has been ex Managing Director Knorr-Bremse India and ex CEO of Escorts Rail. He has over 30 plus years of railway experience and has closely worked on AI applications in railways. So he would be sharing his learnings, experience, and insights on AI applications pertaining to railway systems. With this note, I would like to, for people who are not who are attending our master classes for the first time, I would like to briefly share about our organization. So, Railway Academy is a railway sector focused training organization based out of India, and we conduct programs in collaboration with world's eminent institutions and universities. So here I would like this program, this masterclass is an extension to our certificate program in artificial intelligence and data science applications in railways, which we conduct with IIT Madras Pravartak. We've recently completed a batch, our first batch of railway professionals who have undergone 6 months of training under IITM Pravartak faculties, railway experts on artificial intelligence and data science applications. We got representations from Alstom, Etihad Rail, Chris, Sydney Metro, Indian Railways, Wabtec, Siemens, 25 plus countries from five different companies from 5 plus countries with 45 plus registrations for the course program. They've underwent this uh, specific program, one of its own kind, on AI applications in railways. And those of you who want to know more about the subject, this is the extensive program, and you could check out this program onto our website. There's a dedicated course page which you could actually go through to know more about what aspects of AI we are covering. And if you are interested, you could get in touch with us. With this note, I would like to welcome our expert Deepankar sir to start the session. There are a few rules we've set to make this experience very valuable. First, we'll take a break around 8 o'clock for 5 minutes, 8:30 for 5 minutes. You could, if you have any questions, queries, please put your questions and queries in the chat box. I'll take them up at appropriate intervals, or once Deepankar sir's presentation is completed, I will take those questions and get them answered by Deepankar sir. So, in the meantime, please enjoy the session. If you have any questions, please put your questions in the chat box. This session would be recorded and would be and we are looking at converting this program in the form of a course very soon, about which I will share the details at the end of the session today. With this note, welcome sir, and kindly begin the session.
Can you see my screen?
Yes, we could see your screen. Yes.
Okay. So very quickly, I'm Dipankar Ghosh. I have been into the railway and the mobility sector for quite long. Had been with the MD and the board member of Knorr-Bremse Rail India recently. Before that, I was the CEO of Escorts Rail Division. And I had also experiences building the Bombardier Rails Center of Excellence, which is now with Alstom. And also before that, I was the Indian Railway Service Officer with the Indian Railways and had been a major contributor for the technology transfer for the ABB high horsepower, which you see the WP5, WP7, and the WD9A. These are the locomotives which you have in Indian Railways. So quickly moving on. So what we will touch today is something like this. We will talk about it, the introduction. Why do we need AI in railways? What are the enabling technologies? I'll try to make it more simpler because there's a very mixed sort of a crowd, I suppose, so that everyone can relate to what is AI and what is the magic behind the AI. And similarly, we talk about the few use cases. We take real life use cases for predictive maintenance, passenger service operations, and in safety and security. And lastly, we will talk about some briefly about the implementation challenges and the leadership actions what we take. With that, one, we need to be very I would say the precursor for anything to do with AI is the availability of data. So unless you have a digital transformation happening in whichever railway portion you have, you are not able to actually get any sense out of AI or any sort of a use of AI in any portion of the railway sector. So wherever you are working, wherever whichever subsystem you are working on, or whichever section of the railway ecosystem we are working on, data is very important. But traditionally, obviously, railway had huge issues of data, but now things have changed a lot. So that way, digital transformation is a precursor for use of AI. Even though you may be using AI in very small pockets of this thing, but if you really want to have a implementation at a larger scale so that you get the benefits of AI, we need to have something like the digital transformation already happening in the railways. Now, what is happening is that you have issues. Uh, Sorry, you have issues like unless we do have this particular transformation happening, unless there is a data network or a data ecosystem out there, you won't be able to really have an AI. With that, what I will also need to share with you. So what I would be sharing with you is something like this. I mean, for example, as someone who has spent decades in railway leadership and had the privilege to partner with many railway OEMs, be it Alstom, be it Siemens, be it CAF, around the world, and more specifically last few years with the German multinational Knorr-Bremse, who are the leaders in brake systems all over the world. So we have seen the I have personally seen this transformation happening for the digital transformation, for the use of AI and different machine learning algorithms, and also different predictive analytics happening in real life case studies. So what I have tried to do is I have tried to capture each of these things in the presentation for. So it is not just an enabler, it is the foundation. That's what we were talking about. And all of you appreciate that railways always generate almost petabytes of data, of both structured and unstructured data, starting from the low level accelerometers to even the CCTVs, even the control room data. There are a huge amount of data available. But how do you make sense of the data? How do you get insight of the data? Is the name of the game, if I may say. And that is why digitization and, as we call it, data plumbing is very much required. So AI in reality is not magic. It is the more of a disciplined conversion of the data first into a analytics engine, and from there you can identify patterns using machine learning algorithms, and from there you can get insight. That's the whole idea of the so-called use of AI in railways. So you have a digital transformation which gives a clarity about what exactly to be done. From there, we put the data analytics, be it big data or be it some customized analytics tool. And from that analytics tool, you have the machine learning algorithms. We'll briefly talk about what sort of a machine learning algorithms are being used now for calculation of the rest of RUL, or the rest of the balance of the residual useful life of those subsystems, or maybe what would be the pattern of passenger flow, or what would be the pattern of any sort of a I would say any sort of a cyber threat or any sort of a threat which can come in. And there, from there we get into a what you call an artificial intelligence game. So today, what is happening, if you read any of the reports anywhere in the world, from the McKinsey's, from the BCG's, or any of the other reports, you would see the globally AI enabled railway market size. It was around 2.32 billion in around 2024, but that is supposed to reach almost 3 billion by 2026, and it is predicted to be almost reaching somewhere around 5 to 5.5 billion by 2030, with almost a CAGR of 9.5 to from 2025 to 2030. Now, this is only the direct use of AI. you would be surprised there are lots of use cases of AI, particularly people who have joined from the Middle East. There are lots of systems like the Alstom Health Hub, similarly the CAF Lead Mind, similarly the Siemens Rail Agent. These are the systems which are already using, or it is the manifestation of the machine learning algorithms and the artificial intelligence in those systems. So any one of you who have been working in those systems, we don't have those applications till now in India, but whatever you see in even the so-called ETCS level 2 or CBTC applications, it is somewhat related to those things, but not exactly machine learning algorithms. But if you go to many of the other, particularly the Middle East and also to the European market, you would see all those applications out there. So what happens is that once you so what we are trying to say out here is data is a raw asset, and the analytics what we see in this particular zone is it is trying to extract the meaning of the data. Once you have that particular data in a particular format, the machine learning algorithms help in understanding the patterns in the data, and uh, which is not possible for a human being to understand. So the different reinforced learning algorithms, deep learning algorithms are able to understand the different patterns, and are able to understand what I mean, for example, which parameter leads to which sort of a event, and which event is also connected with other multiple events. So these sort of a I would say the connection, the pattern is actually being taken out by the different machine learning algorithms, and from there the artificial intelligence is able to create lots of insights for the operators of the railway operators. So technically what is happening is, by digitizing first, most of the global railways are now able to unlock the ability to apply AI primarily in predictive maintenance, passenger operations, safety, energy optimization in a way that is far more reliable, sustainable, and aligned with the broader goals of the railways. Because it is not possible at times by manual or simply human intervention to create such sort of a ecosystem so that it is always able to give you an insight. And the beauty is the system is able to learn. So whatever happens today, I mean, the system is able to learn and derive patterns and derive the insights out of it, so that I mean, maybe even a year later, when you have a sudden sort of a problem, you are able to understand, or you are able to train your team to respond to such situations, and they are not left with any particular, I mean, what to do and what not to do, sort of a situation. With that, if you see the UIC report, you every one of you would know the UIC, because railway, I mean, almost the UIC is a body which no one can say they do not know. So the primarily, if you see the passenger flow, the predictive maintenance, the energy efficiency, these are the places where the digital transformation and the AI use cases are being put. Similarly, if you see the if you do a technology maturity versus business impact, I think we see that the passenger experience is the highest, where you have all those different passenger information systems available. Like if you see anywhere in the Europe, or anywhere in the even in the Dubai and many other places, or even in Riyadh, you see the mobility as a service, where a guy or a lady is able to plan a journey from A to B with multiple uses of different modes, maybe a car hailing app, maybe a regional train, maybe a metro, and finally to a bus. All this can be seamlessly done using different machine learning algorithms, and the fact that the data is available with us. So that way you have a mobility as a service, or a mass operator trying to aggregate the different modes of transport to give a very seamless passenger experience. We will talk deeply about predictive maintenance, because that's where almost 70 to 80% of the use cases of AI is there. And we also talk about briefly about the autonomous operations also. And now the question is, why do we need AI now? The railways is a very traditional and a foundational, I would say, a mode of transport. So why do you need AI now? Now you need AI because there is a huge modal competition which is happening in the railways. The railway is now struggling to meet up to the road and the air travel. Because both road and air, as you would see, have often been much more quicker to adapt and leverage the advanced technologies. And this way, they are able to not only provide the first mile but also the last mile sort of a effect to the passenger and to the freight. So that way, they do have that sort of a experience which is not being provided by the railways. Similarly, the trucking, they have now getting into the fuel efficiency. They are going into the autonomous vehicle technologies, and also with that they have quite a significant amount of modal competition. So that way what happens is that railway would be forced or now forced to use digital technologies to increase their much more aging assets, and also in a way to improve their efficiencies. So obviously there are, as you can see, many of the, except maybe few of the Middle Eastern countries and few of the places where you have new railways coming up, greenfield projects, a lot of greenfield metros, greenfield projects coming up. Most of the places you have a huge capacity constraint. Why? Because like if you are in the UK, the assets are almost reaching their end of life operation cycles. If you are in from India, then what happens is if you go to the Indian Railways, what happens is from the 1950 to almost 2017, the railway route kilometers have increased by 23%, while the passenger and the freight traffic over railway network has increased by almost 1300% and 1600%. Unbelievable. I mean, the fact that the railway is still running Indian railways and still doing it, we should give a huge credit to all the railwaymen out there in India. Otherwise, that's why you have traditionally low speeds in India, and also it's difficult to increase the speed because of the mixed mode operations. You have the goods train, you have the normal slow trains, and everything is out there. So it's difficult to do that. So then obviously you have the so-called customer expectations, because these customer expectations obviously has been changing, because the evolving customer expectation for both the freight and the passenger, they are, I think they are increasingly demand much more greater flexibility, much more greater transparency into the services which they are buying from any of the global railways, and they want seamless experiences. They are not ready to, I suppose, take the inefficiencies built in into a railway, because that's what is what they are not expecting now. And what is also happening is that everywhere we go, from the Facebook, from the Twitter, from the Instagram, and you name it, you have an omnipresence of digital channels. So this has also elevated most of the passengers, or all of us rather, making the overall the passenger experience a very paramount factor of driving this particular thing. And obviously, all of us know that the overall sustainability, the carbon footprint reduction, the cost optimization, obviously, railway, like the sea or the ocean fare, is one of the most sustainable sources of transport. So that way, you do have that sustainability angle. Wherever you have the sustainability in place, you need to have use railway as a major backbone before, because that way you save. If you'll be surprised, you can Google it up. A single fleet of train from a point A to point B, almost, if the we assume point A and B maybe 1,000 kilometers apart. So a train operation between the 1,000 kilometer operation almost saves 280 to 300 trucks. So that's the amount of carbon footprint reduction which a rail industry can bring in. But unfortunately, unless the railway industry is able to get into something like a more how do they use the data to become more efficient, and how do they can uh, use their assets in a much more efficient manner, that is a thing which is happening out here. And if you see any of the European railways, like there are lots of initiatives going on, shift to rail in Europe, which are planning to cut the railway life cycle cost by as much as 50% and double the railway capacity. So that way, the use of the modern tools, use of data analytics, use of digital solutions, use of AI become very, very important. With that, I move on. So, what are the use cases in the AI rail industry? Now, there are, as you can see, lots of use cases in the rail industry. Once you have the data, obviously you can do a lots of so-called use case. First, the digitization of operations, where you predictive maintenance. That is the I suppose that's the maximum use case what you see in most of the global railways, using lots of IoT sensors, data analytics to forecast and prevent equipment failures. Obviously, you can predict the failures using condition based monitoring, and you can create lots of last minute run to failure events. Similarly, you there are lots of digital twins which are coming up, where you can simulate the operations and optimize the performance. Then you have the smart infrastructure, where we are embedding sensors for continuous asset monitoring. And with that asset monitoring, most of the global railways are able to do a life cycle optimization. Obviously, that also gives a lot of energy efficient systems, and lots of sustainable features are being built in. We talked about the passenger experience, contactless ticketing, user friendly mobile apps. I mean, it's only the I would say, since the data and the AI models are available, it's the imagination of any of the entrepreneurs to really create value and create business in this particular ecosystem. Similarly, you have the autonomous and the semi-autonomous trains. We know about the ETCS level 2, the ATPs and the ATOs. All those things are also something which gives you that particular. Similarly, if you see the decision making for any better, any capacity planning, any maintenance planning, anything you do, you if you have this demand forecasting, better demand forecasting, since you have the data and since you have the ability to use a lot of inexpensive, I would say, machine learning algorithms, that gives you a huge amount of insight into the data, what to do, what not to do. One. Second, you can do a lot of scenario planning, because if this happens, then what should we do? Even if it doesn't happen now, your team, your so-called operations, maintenance, and any of the other team, they are able to plan the scenario. I mean, even though the scenario has not occurred, using a digital twin, like if you go to SNCF or the French railway, if you go to the Trenitalia, the Italian railways, or if you go to the Deutsche Bahn, the German railways, they have created lots of digital twins almost for almost whole of the railway system. So they are able to plan, and they are able to do a what if analysis of what can go wrong, and how they can need to tackle if this goes wrong, without touching the physical railway asset, or without going to the physical railway asset. So that way, what happens is the teams are far more better prepared to handle any sort of an emergency than when you are not using the data. The Obviously, many of you would feel, what is the advantage? I mean, obviously AI is just like a automation sort of a thing. No, it is not. Why it is not an automation? Because the AI systems, with the amount of data for the health and safety of many of the railway maintenance, or by the subsystems railway subsystems, are able to railway subsystems, what happens is the AI systems can now detect potential hazards from track defects, from broken rail joints to objects on lots of either on the line or on the unauthorized individuals, and this so this helps the AI pod system to do a lots of optimization. So what am I trying to say? The if you see, it's a huge paradigm shift from a typical rule-based automation. See, automation was more of a rule-based that only to a far more intelligent systems. Here, the system is able to learn, adapt, and then predict. So I'll focus on the three words: learn, adapt, and predict. Why? Because the system is continuously learning, the system is continuously getting the data, and it is able to adapt to the data, find out any anomaly in the data, and accordingly create an insight. That particular insight is also stored in the system to take care of any other anomaly going forward. So that's the amount of learning which is happening. So learn, adapt, predict, which is not possible with a pure automation system. So similarly, you have the cognitive infrastructure, the railway systems that understand context, anticipate needs, and make intelligent decisions without, I would say, any human intervention. Similarly, I mean, some of that, we have seen everywhere, wherever you go, you have the driverless trains, but these are far more lower application of AI than what is possible and what is being done everywhere. Similarly, the predictive intelligence, moving from the typical scheduled maintenance to more of a condition based maintenance, and from a very reactive problem solving to more of a proactive optimization, similarly, dynamic adaptation. So, these are some of the things which are uh, being brought by the use of AI. And what is also happening is that with the availability of huge amount of data, with the availability of the data analytics tools which can configure the structure unstructured data together, with the fact that you have lots of inbuilt I would say the deep learning and the machine learning algorithms available, like the forest algorithm, the ant colony optimization algorithm. There are a lot of use cases which can be taken off, and these are not which I am talking about as a science fiction. These are already being used. These are already being used in many of the railways. As we go deeper, we will see. So this is something which is already being used. If it is already being used, so it's only the question of how you as a leader, you as an engineer can think of what can be done for use of such sort of a algorithm, and where the data is can be picked up, which sort of a sensors can be used. These are what we need to see. With that, I move on to industry specific, obviously asset longevity, and there are cases where you have the because most of the railway infrastructure obviously works on 30, 50 years, and the digital technology is coming out in exponentially faster. So that way, digital technology and AI is able to extend the life of the existing assets. Similarly, the network effects. Railway, if you need, many of you who are in the railways always will appreciate that if you have a fault in one portion of the railways, that because of the network effect, it is actually spread out in many other places. So that way, how I mean, one particular system inefficiency can spread out, that also we can simulate using AI, and it helps. It can help with the insights of the AI to optimize obviously multiple variables and constraints to uniquely suited to the railway operation. This is very difficult for I would say a controller, or for any other man or a human being who is trying to do that manually. It's You can do it, but there'll be huge inefficiencies. So that way, with the availability of data, with the availability of lots of I would say the machine learning algorithms, you are able to do that. Obviously, uh, you would understand that these particular uh, algorithms also helps us to give you that particular benefit of I would say, before any accident happens, you have the advantage of getting into much more details. Any questions so far? I am not able to see the chat. So if you have any questions.
Sir, there are very interesting questions coming up, which I think that we should take it up after the break. I think
Okay,
please continue.
very
Yeah.
good. So now all this, whatever we discussed about the AI, the machine learning, you may feel that, oh, okay, you have the data, so you do the analytics of the data, and you need to put some standard machine learning algorithms to do that. Now it may look simple. Obviously, it's not that simple. I am just trying to explain the overall architecture of how it is done and how we can use different algorithms to actually get benefit out of it. One. Second, there is a huge amount of, I would say, all of you who are in the railways know that railway is a very conservative thing. People don't believe, oh, this can happen, this can go wrong. They have lots of experiences which they usually do not believe in the systems and the software. But it is not software. It is far beyond the software, because here what you are able to do is that you are able to connect the thousands of dots all across the ecosystem to actually come out with a pattern or come out with an insight, which is not technically or even physically possible for any human being to do that. So that's the advantage of using AI or data analytics along with the AI, because with data only you have this thing. I mean, with that only you have, I would say, the possibility of using AI. Now, AI, whatever we say AI, many of the cases you will feel that AI is failing. It is not the problem of AI, it is the problem of the digital stack. If the digital stack, which enables the so-called use of AI, if we don't have the digital stack ready, you can have any sorts of fancy machine learning algorithms, you can have any sorts of fancy data analytics patterns and all those stuff. It will not work. Why it will not work? Let me talk about that in the coming section, which is the enabling technologies. Now, for the particular AI to happen, the basics or the gut of any AI system application anywhere in the railways or even in the modern industry starts with this digital stack. What is the digital stack? You have the IoT sensors out here. From there, you have, we call them a digital stack for the AI. Now, you have the sensors, you have the connectivity, you have the data platform, the models, the operational action, and from there you have the different sorts of sensor edges, and you have the connectivity. Today, because of the latency and because of the use of such data heavy algorithms, you need 5G or even the new IP-based future rail mobile communication system, which is now very prevalent anywhere in the Europe and also many places in the Middle East, and in a way a version of it in China. So that way, this data network is becoming very important. And you have the different, ultimately what happens is you get the dashboards, you get the alerts, you get the control. I mean, there are cases where for the condition monitoring systems which are available in the real life cases in Deutsche Bahn, in SNCF, in SBB Swiss Railways, they are claiming in their annual report they're able to save more than 25 to 30% of the maintenance cost. Now, many of you will not know that the whole life cycle of a railway asset, 65 to 70% of the cost of that life cycle is maintenance. So that way, the predictive maintenance and everything. What is axle box temperature? Axle box temperature is the axle counter is different, axle box temperature is different. It is a sensor in the axle box housing where you are able to monitor the temperature, so that if there is any friction or if there is any untoward event happening in the axle box, you are able to understand that. Anyway, let me move on. So with this sort of a digital stack, what happens is you are able to get into the vehicle sensors, the trackside sensors. there are a lot of sensors in the train. I'll come to that in the next few slides. And we are able to get into a mode where you have a real-time analytics for the train, not only for the train, for the wayside, and for any of the other assets, depending upon the maturity of your railway ecosystem, which is already there in many of the European railways. India, we still do not have those things, but we do have started the huge amount of data collection for each coaches, the smart coach concept, the PICU or the smart coach concept, which has come in. So that is there, but we don't have the full-fledged ecosystem, still not there, but very soon it will be there. With that, we come to something like a cloud computing and edge computing. Sorry. Quickly, I mean, Sumit, can you disable the chats coming on? It's a little bit disturbing. I mean, you can have the chats, but they did not come in the Zoom itself. Nevertheless, so
Let me see if I could do that, sir. Right.
So the cloud computing, I mean, obviously we know about cloud computing, where most of the whatever data we are doing, whatever data is being sent to the cloud, obviously you need lots of optimization there. But what happens is that for any particular critical decision which has to be taken into this particular train or any railway subsystem or any railway ecosystem, then you need edge computing. Edge computing is something where the processing is of the data for an insight, for an actionable insight, is done at the source of the data itself, with the edge computing devices available in the train, in the coach, or even at the wayside things also. But usually it's in the coach. Wayside is quite recent. I mean, primarily it's in the coach. And so depending upon the criticality, if it's a time critical data, if immediately you have to act, then you need edge computing. If you need a normal train data which is trying to learn and the system is trying to learn and trying to find out any pattern deviation, then you go for cloud computing. And last but not least, you have a digital twin. The digital twin is something like you have a digital twin which is a virtual replication, if I may say. This virtual representation of any physical object, for example, be it a locomotive, be it a coach, be it even a track. So these virtual representation as a digital twin, I mean, many of you would be knowing the building BIM models. So BIM is a precursor to a digital twin. So once you have that particular physical object or a system mirrored into a digital twin, what happens is that you are able to do lots of simulation analysis, lots of simulation, real-time performance analysis, scenario testing, lots of predictive modeling, lots of life cycle optimization. These things actually give that particular digital twin. The advantage is that the railway operator need not actually go to the physical asset to see what is happening out there. They are able to do simulate and do lots of WhatsApp analysis on the digital twin itself. And this is possible because of the huge amount of convergence of IoT data, AI analytics, and simulation there. Now, why am I talking about this? I'm talking about because these are the architecture, or these are the basic building blocks of use of AI in railways. So that's how obviously railway is able to do that. And there are a lot of predictive maintenance, lots of simulation, lots of this real estate management also happens, the predictive analytics, lots of these things happen using a digital twin. And digital twin is not that it's a science fiction movie or something. It is already happening in many of the railways, be it in UK, be it in Trenitalia, be it in SNCF. SNCF and Deutsche Bahn has gone 2 steps ahead with digital twin. Their whole of the railway assets have been created as a digital twin. And the beauty of the digital twin is every day you have a problem, every day you have issues. The digital twin is learning and becoming more and more intelligent to help in the scenario planning, to help in the what if analysis, and help in the different predictive maintenance simulations and everything. So now we discussed about the overall what is happening in the railways, what are the enabling technologies, starting from the digital stack. The digital stack is basically where you collect the data from the huge number of sensors across the railway ecosystem, and you are able to get lots of data into the system, and the system is able to understand what is going wrong, what can go wrong, and if something goes wrong, what other subsystems can be affected. If those subsystems are affected, what should the maintenance team, what should the operations team do? So all those planning can be done by simulating the so-called digital ecosystem. And the digital ecosystem is basically the confluence, or I would say the convergence of the data is the digital twin. So I move on now. We talked about all those stuff. Let's, many of you who maybe knew, the railway system also has a lots of data. What are the data? So you have the information systems, you have the multimedia entertainment solution, the network connectivity, the smart ticketing systems, and even in India you have the freight information system, FOIS. If you many of you, if you have similarly, you have the train control systems where you have the ETCS, the ballast data. You have the GSMR. Now the GSMR is being replaced by the FRMCS, and also the GPS and the GNSS systems. And there is also lots of data available even in the power supply systems and the smart metering systems, which are now being used to bring in lots of efficiency in the system. So and you also have the smart infrastructure, and then you have the predictive maintenance. So the whole idea, what I'm trying to push is, the true value of AI in railway lies not in isolated applications, but in its ability to create a digital twin of the entire railway network. So by integrating the data from the rolling stock, the tracks, the signals, the stations, AI can create a real-time holistic view for the operator or for the railway managers, just to simplify it. So which enables a very proactive system-wide optimization rather than a traditionally reactive siloed problem solving. This is a huge amount of game changer which is happening out there. So so that's why, I mean, now if we go to this particular slide, so you have huge amount of different type of sensors in different places. I mean, I'm just trying to capture it in a like in this particular thing. For example, leak in India also, in the smart coach we are putting leak detection in the overall passenger car water reservoir, so that if there is a leakage, the system understand that there is a water leakage in the particular reservoir, the water levels are down, or maybe if there is an issue with the HVAC or the air conditioner filter, all those are able to be done. And with that, this data we are calling a digital nervous system of the train, and this is available across the globally. Even in India also we have it. China and all these people, they are far ahead, so they also will see how they are managing driverless trains at 350 kilometers per hour. So that will come later. But if you see the digital nervous system, so you have the train. In the train you see so much of I suppose systems are there, from the HVAC, from the bogies, from the passenger information system, from the toilets. Even the toilets are also fully sensorized, and the doors and the different other things. With that, you are able to generate not only data, but also able to understand whether any of the subsystem out here can fail. If it has to fail, it will give you lots of data, like a vibration signature, like the temperature, or different patterns in the motor current. In for example, a door. Let's take the case of a door. In the door, you have the two leaves, and you have the door drive on the top. Now, if there is any issue with the door drive current, and the vibration and the temperatures of the the so-called road drive motors, you understand much before that this particular coach door number this, it has a potential to failure in maybe 2 weeks from now. So you are not affecting the passenger operations because of this data availability and because of the fact that the AI is giving you a predictive maintenance alert that this particular door has a issue. So you know exactly what should be done much before the door actual failure happens. So that's the beauty of use of AI. So let's quickly talk about the predictive maintenance in the railways. So the predictive maintenance ecosystem of a train is like you have lots of sensors out here, which we saw all those sensors. So so these particular sensors, you have a data aggregator hub out here. In the data aggregator hub, so the data aggregator hub is what we call the system and the sensor integration. From there, we are able to create real-time alerts, telemetric data is also there. Obviously, we can capture different train performance data, and with that, you can do a lots of predictive analytics. We are building a data warehouse for the train data, and this train data finally maybe few years from now you will have, you know about chat gpt, you know about Claude, you know about the so-called perplexity and many of the Google Gemini and all the stuff. Now they work on the large language models. So the large language models have been built for a huge application by many of these OpenAI and many of the Googles and the other companies. So many of the railway operators are also having a data warehouse where they are talking about having their own localized LLMs or the localized large language models very specific to the railway applications. And finally, what will happen 10 years from now, many of the operators like a Deutsche Bahn or an SNCF or many of the, they will be sharing the LLMs with that. So many of the faults which has happened in a so-called SNCF or a French railway TGV can give lots of inputs about what could have gone wrong, what could have been handled properly, to even to the databases of or the large language models of the Deutsche Bahn. I mean, I'm just giving you how things are moving. Whether it is happening or not, I don't know, because that's what we see how the large language models are actually coded in between. And now we are talking about localized large language models specific to the railway operation. So with that, what happens? You have the operational status alerting, we have the operational insights into this, and you have the predictive maintenance and the service scheduling issues. With that, I'll just give you one quick example about how even a bogie, the railway bogie, any one of you knows the railway bogie out here is basically you do a vibration analysis. Similarly, you can do a sonic acoustical analysis and obviously ultrasonic acoustical analysis. So all these analysis data is being fed to the system, and the system is continuously learning, and the system is able to understand whether there is a difference in the pattern. If there is an anomaly detection algorithms are there, the anomaly or the difference in the pattern, it alerts that there is a vibration out here in the particular bogie, or the current temperatures are going much higher. With that, what happens is the maintenance engineers or the depot engineers are able to get a far higher alarm, or the time window to attend to this particular bogie problem is far higher than when you come to know about it far more later when the already failure has happened. I'll quickly show you. Now we go into real life cases. Okay, just a minute. I hope I am able to. Okay. No, let me go. So out here, this is a real life case study from Singapore Metro. In Singapore Metro, what they're doing is they're putting lots of these trackside sensors, and they are putting in a lot of accelerometers in the so-called axle box and in many of their axles. Now, what is happening? You would be surprised. Even your iPhone or normal phones also have accelerometers. So today we have very low cost accelerometers available. Now these are not low cost accelerometers. What I'm trying to say is accelerometers are easily available in the system. So if you have all those accelerometers and this G detection, the vibration detection sensors in the axles, and the car or the trains are regularly moving and continuously seeing this data from the trackside sensors, we are able to understand whether there is a fatigue in the track, or if there is a issue with the wheel. So the rail wheel interface, if you many of you in the railways will understand the beauty of the rail wheel interface. The rail wheel interface is what actually drives railways. Now, if you have any problem with the rail wheel interface, you will have some kind of an accident, or you will have some kind of a. So let me
After this
complete
slide,
this
we
slide.
can take, let's complete the slide and then we can take a
Yeah,
break.
yeah. So this particular system, what happens is that this is able to understand, or the train operator, in this case SMRT, we call them SMRT. These are the Singapore Metro. So they are able to understand and utilize the data to improve the rail reliability. Even they're able to predict the waiting time for the customers in case something happens. They call this TTCM, this particular system, train and track condition monitoring system, which uses, as we see, a fiber optic sensor to detect any abnormal vibration in real time. And these vibrations are very commonly used to either detect the train defect or the train wheel degradation. Now, any one of you would understand, as I was saying, that anything to do with rail wheel interaction, the rail is this particular rail and the wheel interaction. This gives the system an alert that there is either a problem in the axle, or there is some G issue in the coach riding comfort, or there is some issue in the wheel, or there is some issue in the track itself. So that way, the whole system understands that there is some issue much before the system actually happens. So that way, the maintenance, or the so-called condition-based maintenance, or I would say the precursor to a predictive maintenance, this gives the enough time or window for the depot managers, for the people who are the stakeholders in the system, to act much before anything happens. With that, we'll break for a bio break, or maybe a whatever break you want.
So we'll take a 5 minutes break and we'll reconnect at 9:32. Okay. So once we come
9:32
back,
or
I'll
8:32?
8:32, sorry, 8:32. Sorry. Another five. I'm putting a timer on here for next 5 minutes so that
So we heard about the predictive maintenance of the axles. We heard about the predictive maintenance. So now you would be surprised. This predictive maintenance is being used in any, I would say, any sort of a system which is important. Like all of us, many of you are signaling engineers out here. So you know the railway points. So the railway points are very important. I mean, let me move this out. Oops. Uh, So the Deutsche Bahn, what they have done is they have developed a system called Dyna. Now, what the Dyna does is they are able to monitor each and every point machine. So the point machine, using the point machine data, they're able to do an intelligent data analysis, and using different anomaly detection algorithms to help and understand what can go wrong and what is the problem. So the all of you know the railway points or the switches is a very vital component of any railway interlocking system, and the regular maintenance of points is done to keep them in operation. Now, the Deutsche Bahn system, the Dyna, is a advanced condition monitoring and diagnosis solution for the infrastructure of assets. With this, the huge amount of data that they are able to pick up regularly, and without any intervention of any human out there. So the massive data, they're able to do a very intelligent data analysis using random forest algorithms. These are all names of different machine learning algorithms using different sorts of algorithms to detect basically the anomaly. If the data was flowing from each of the points in this way, the power consumption, the vibration, the temperature was in this mode. If there is sudden change in any of those parameters for any of the points, the system picks it up and tries to monitor that particular point in a more focused way. And with that, they're able to understand whether there can be a problem with that point much before the actual problem happens. So that way, the operations is not affected. They have very high reliability, availability, maintainability, and serviceability of each of these points. So all of you know about ramps. The ramps figure for these points, because of such Diana systems, they are able to get very high RAM score for these things. So I move on to, if you see, many of you know, particularly people from the track or the civil background, that the track failure is a major issue of all accidents. If the track fatigue happens, if the track fails, you have a massive accident, and that is a huge issue. So with that, you have the ultrasonic sensors which detect different this thing. So now what is happening is that you, due to the availability of sensors, you are able to monitor the rail profile, similarly the track geometry, and these are all done in real time. And you can use different cameras and machine vision in the coach, under frame of the coach, so that you are able to understand what is happening in the track. That way, the track failure, the track fatigues are able to be known far more ahead of any such thing happening. So that's the amount of technology. And this particular technology, since you have regular data, this data is being picked up and then being put into the different sorts of AI algorithms to give you a very deep insight. Now the bridge, many of you, obviously you know, particularly in India and many places, railway bridge is a, I suppose, is a very critical asset. And many places, like if you go to the US railroads, you have almost thousands of bridges every 50 kilometers of the track. Same for us also, maybe 100 kilometers or so, depending upon. So bridge is a very critical asset. So what we are now doing is, we are putting in lots of sensors. And these sensors are very inexpensive sensors. These sensors are put at different points in the bridge. So you have the wind velocity detection, you have cameras, you have weighting sensors, and you have lateral acceleration sensors, temperature, humidity sensors, similarly vertical acceleration sensors. All these sensors are actually finally able to generate this sort of a data. So with this sort of a data, you know exactly what is happening to the each of the part of the bridge. And this is not being monitored by the humans. This is monitored by the AI and the machine learning algorithms, who tells you where you have a problem in case if you have a problem in this thing. And this happens far more away, I mean, far more before such problem happens. So this, what happens is, this gives you a huge amount of insight into the health monitoring of that particular bridge. And this can be integrated to a digital twin of the bridge, so that the you can know that if there is some stress happening, or the stress strain, or as we call them, von Mises stress strain plots. You would have heard in your physics classes in 11 12. So this von Mises stress strain plots can be collated, can be data can be extracted, so you know exactly which point in the bridge is under huge tension, and which point has to be buttressed with some sort of a maybe additional structural enforcements. With that, I move on to the Deutsche Bahn real life case study. Now, in this real life case study, it is a predictive maintenance which is being done at Deutsche Bahn. Now, Deutsche Bahn, what they do is, they have put in almost 500,000 IoT sensors everywhere. They're monitoring the brake system pressure, they're monitoring temperature, bogie, vibration, and they are able to it's something like the Deutsche Bahn embarked on their AI journey almost in 2019. They weren't just implementing technology, they are fundamentally reimagining a 200-year-old industry approach to one of the most, I would say, the critical challenges, keeping trains running safely and efficiently. So you have almost, as I said, 500,000 IoT sensors across the rolling stock monitoring, brake system pressure, temperature sensor, bogie vibration, acoustic monitoring, wheel. I am only capturing few of them. There are many more. So wheel rail interface. We saw the wheel rail interface in the Singapore Metro also. Similarly, HVAC system performance. You can even optimize depending on the occupation of the coach. You can even optimize the HVAC so that you don't need to run both the HVAC in all the coaches. So because why it is important, because HVAC is almost 25% of the energy of a coach. So that way you are able to, even if you save 12% of a coach energy, or maybe for 4 or 5 coaches out of a 16 car train formation, and that happens for over a 6 months, you have saved a huge amount of energy. So I mean, I'm just trying to connect about what is happening. And what they are doing, they're able to get a 40% schedule maintenance is becoming unnecessary. They're expecting almost a 20%, because this unexpected failure used to cost 20% all passenger delays, that they have almost taken care of. And uh, obviously there are lots of disruption euros which they call that is happening. I mean that can be prevented. So what sort of anomaly detection they are doing? They are using, I mean, I didn't mention here, but people who are interested, unsupervised learning algorithms, which are able to identify deviation patterns in the sensor data, or a time series analysis, which can detect any subtle changes also in the component behavior. And obviously, you can put in a multivariate analysis, which can correlate failures from different systems. So technically, what we are trying to do is we are doing a remaining useful life prediction for the critical component. We are able to do a failure probability calculation, and the whole idea what there is that the architecture of the sensor architectures, they have created a comprehensive digital twin of the whole train because of the data they have collected, and where each brake pressure sensors, bogie vibration monitors. See what happens is if there is a anomaly in a bogie vibration sensor, now that it can happen two times. The cause can be two: whether there is a real vibration or the sensor may be faulty. For that, even if you do a cross sensor, I would say cross sensor validation, like you check the validation of the other sensor of the same bogie, or the other two sensors of the other bogie of the same coach, you obviously know that there is a vibration there also. If the vibration is not there and the vibration is there only at only one point, then you can safely neglect that because it's a sensor failure. The sensor has to be replaced in the next depot run. So this is how it is being done. And they are now claiming, I mean, it is not claiming, I claiming would be a wrong this thing. If you go to the Deutsche Bahn annual report, Deutsche Bahn is a listed company in the German stock exchange. So, and for us also being, since I was from the Knorr-Bremse and we had number of meetings with the Deutsche Bahn management, so they are saying that they are able to save 125 million euros. 125 million euros. You understand how much of savings potential they have, and they're able to. The biggest thing is money is only one part. The biggest thing is their maintenance teams have now shifted from the, I would say, a firefighting mode, reacting to failures always under stress, to more of a chess master mode. What do you mean by chess master mode? They are thinking multiple moves ahead. So the 45% reduction in unplanned maintenance events means that trains spend more time serving passengers instead of less time in the depots and the rails. So the train is actually doing a commercial run much better than what they otherwise what they would have done if you have this thing. So this is what has happened is this is a huge amount of thing which has happened for the Deutsche Bahn. What are the measurable outcomes? We discussed 45% reduction in unplanned maintenance event, 32% decrease in 18%. And this is not what I am trying to tell you. This is available in the annual reports of Deutsche Bahn. So if you want to go deeper, Please go and check the annual reports of the Deutsche Bahn. You would see these things. These numbers are all picked up from their annual report. This is a publicly, they are trying to say they are so proud of the fact that they have done this. I mean, this is only one case study. You have hundreds of case studies from Deutsche Bahn, from SNCF, and many of the others. I move on to the UK Rail. Now, in the UK Rail, what you see out here is by Hitachi. The Hitachi, what they're doing is they're putting in a lot of wireless monitoring technology with their startup ecosystem called Perpetuum. Interestingly, Perpetuum has also supplied lots of sensors, piezoelectric sensors, to our Indian Railways also for the smart coach applications. So the Hitachi's Perpetuum onboard system is live on many of you. If you have been to UK sometime, Great Western Railway, there is a private railway called Great Western Railway, and there they are able to capture real-time data on wheel sets, bogies, gearboxes, traction motor, bearings, and wheels. With that data, what is happening is they're able to cut down any untoward or unpredictable downtime by almost 50%, and by replacing the 7-day manual inspection. And with that, they're claiming they're getting almost 100 extra days of train availability per year on the G. 100 extra days of train availability is a huge, because it totals around almost 3100 plus days over the fleet's lifetime. Means the fleet's lifetime is now being extended by almost 10 years. So that's the amount of strength what the AI and the data analytics are, and obviously with the sensor ecosystem, is doing to the trains. It's not that we are just talking about it's a fancy thing that whether we should put AI or not, whether we should do this thing. No, it's not fancy. It is actually happening in most of the railways. I mean, in India, it's still we are far behind. We have huge amount of data, but we are still struggling with how many trains, what many trains. But many of the new Bande Bharats and all this new trains, they do have the sensor data already there. It is only a question of time when those data would be picked up from different subsystems of the Bande Bharat trains, or even for the smart coach of the LHB smart coaches, and we are able to build some application around them and get this sort of an insights. So again, this is not science fiction. This is not something which is a theoretical thing. This is really happening in many of the railways. And with that, they're able to do a precise fault detection. They're able to do which impacts their passenger service. And similarly, they're able to future proof their capability. So what is important is future proofing. Why do you mean future proofing? The sensor network can also monitor the track, the axle condition. It helps them to for a full digital integration of the track and train systems. So they exactly know which track, which train, which rail wheel interaction is a problem, and which they can do. And with that, they have been able to also share a lot of data, as I was talking about the large and localized large language models of the so-called Deutsche Bahn SNCF, this which is bound to happen in the few days from now or few years from now. So they are already doing it with their internal so-called other private railway trains in UK. UK has a privatized railway train operation. So GWR, Agility Trains, Eversholt, all these are part of the so-called railway train ecosystem of UK. Similarly, if you go to the OHE is very important, and because of the OHE issues, there used to be huge amount of I would say accidents and huge amount of passenger delay, train delays, detentions, lots of things used to happen. And they used to happen almost 15-20 times annually across the UK network. So what they could do, they have now put systems, roof mounted cameras on the LNR Azuma trains. Now these cameras are only capturing data. What you have to understand is the camera is capturing data. The camera is the sensor out here, and along with that they have the different other pressure, the catenary pressure, the catenary alignment, all those things can be captured. With that, they're using different machine learning algorithms to identify the deviation, predict the material failures, and also they're able to cut down on the visual inspection, which are very manpower intensive and very error prone. So, and with the fact that they are ultimately it's a cloud-based platform, they're able to visualize and analyze the infrastructure data with a very intuitive AI-driven interface for the operator. So the operator now knows exactly what to be done. With that, let me come back to our continent, which where China. Now, if you see China, very interesting. China has done a driverless train operation at 350 kilometers per hour. You hear about in India about driverless metro operation. So that is nothing compared to the this driverless operation at 350 kilometers per hour. And what they have done, they have not only these trains are called the intelligent focusing ATO system. This is connected with their Baidao GPS system. They have their own GPS system, and with this, what they have done is something like this. They have the 350 kilometers per hour train and these branded intelligent focusing trains, which they actually inaugurated with the China Winter Olympics in 2019. And this they use almost 2700 sensors, 2700 plus sensors, onboard sensors, to give a real-time self-diagnostics and a predictive maintenance recommendation. So the train driver and the depot managers, which the train is supposed to service, knows much before what can go wrong. It is not that it will not go wrong, but anything can go wrong. But if you know a month ago that this particular system, be it a wheel, be it a traction motor, be it a catenary, be it anything of the system, that you have a problem, there is a pattern variation in that particular subsystem data, you know exactly that there is something to be sick. And with that, you go deep and you find out what can be done. And with that, they are saying that they will be able to replicate this sort of a thing. This is an 8-car EMU which accommodates almost 560 passengers, and they would be able to do a routine cruise control operation without driver using their Baidao navigation satellite system. So this is the amount of technology which has gone in. I mean, this I would say this is far higher even than the so-called Deutsche Bahn and the SNCF applications. Then we come to their high-speed maintenance. This is, I mean, the cream de la cream of the railway maintenance. What one can have. The Chinese high-speed network. Many of you, if you don't know, it's more than 45 to 47,000 kilometers. If you add up the German high speed or the Japanese high speed or the SNCF high speed or anywhere in the world, they do not come even half of that. So that's the amount of all the cities now have the high speed train. China has invested so much in the high speed network, and it spans almost 45,000, making it the largest globally. I mean, they say it's longer than the Earth's equator also. So these trains operate at 350 kilometers per hour. And in Beijing, they have their own AI control center, which aggregates data from 3 primary sources: rail-mounted sensors, over thousands of high-definition cameras at every places, and the inputs from the on-site track workers, from their mobiles, from their screenshots, because now they have a system where the mobile data is also the structured and the unstructured data, and they're able to collect almost what they're saying is 195 terabytes of data. This 195 terabytes of data, each classified into 57 data types. Why data type? Because what sort of a fault, what these can be classified, they have classified it into 57 data types. And they have been now able to do a huge amount of algorithm out there, and with that they have reached a diagnostic efficiency of almost 95%. So, and minor rail faults have plummeted by, as per their chief engineer's vision out there, is almost 80%. And what is happening is that China, you would think that they have a lot of people, but China faces a skill shortage also. So fewer track attendants are available despite rising demand, because there are many more value-added jobs available in China, so that the track attendants do not want to work as a track attendant. So that's why they were forced to put in this sort of a technology out there, and they're able to really maintain it for the last 4 or 5 years. And it's a perfect case study of how much of detail you can go using AI, using data analytics for this sort of a application in railways. I think this is the peak of the predictive maintenance. What can be done in railways, and they have done it down to the T. I mean, everything which they want, they are able to control. They are able to monitor, and that way they are able to maintain such a high-speed network at almost 95% to 96% efficiency. We'll come to that in the other question, but quickly, now we discussed about so many things. What is the AI and the big data synergy? The big data obviously comes from different processes and all the stuff, and when we put it into AI, we are able to do the data level. That's the overall crux of what we do. And for that, what is the machine learning algorithm we usually select? It depends on what sort of a real data and what sort of an actionable insight what we want. Similarly, what subsystem efficiency we are trying to focus on, what sort of a proactive and adaptive rail system we want, and how we want to shift to rail intelligent rail operations. With that, we talked about so many machine learning algorithms. So this is the machine learning algorithm. What will be anomaly detection in sensor data, failure mode classification, and root cause analysis. Similarly, you can do a remaining useful life RUL estimation. You can do a maintenance timing optimization, and you can do resource allocation for the maintenance management, for the depot allocation. We can ensure which depot has what sort of a work and how each depot can reach their maximum efficiency. And this also the time series analysis, classification algorithms, and also regression models are being used on. We can also do a overall mix and match of work. I will move on to the AI in passenger service. Now, AI in passenger service is that will come to even nowadays what is happening. I'll again go ahead and use a Deutsche Bahn example because of my German MNC experience and because of the fact that I have been privy to the Stuttgart S-Bahn operations quite significantly. So that's why let me talk about the Stuttgart. Stuttgart is a city in Germany where you have S-Bahn. S-Bahn is a surface train. U-Bahn is an underground train, and then you have the metros and the regional trains also. So in this particular application, what is happening is that I would say the managing the S-Bahn operations is like almost as I write here is like conducting a symphony where every musician is moving at 100 kilometers per hour. Who is the musician? This is the train. So each of the train is moving 100 plus kilometers per hour, and any mistake by the controller can affect thousands of passengers. So traditional rule-based systems simply do not work. So that way, they are using this sort of a system where the passenger data flow, the ticketing analytics, the CCTV analytics in these different stations, and the AI is able to capture all the data and do a demand prediction, capacity optimization, and they had challenges in the implementation challenges, but they're able to get finally implemented, finally convince the so-called the train regulators. Why am I showing this case? Many of you would be thinking that, oh, our railway systems are very old, the signaling systems are very old, and our AI and all those mumbo jumbo things are very hi-fi. So yes, it is hi-fi. So how do you connect them? Because ultimately, whatever you do in AI or machine learning algorithm, you have to have an action. For example, you have to make a signal rate or if you move a point machine, it has to happen, right? But these are all old systems, while these are all new systems. So you have something like a middleware platform which has been developed. So Deutsche Bahn is created for the middleware platform which have been developed. Due to this middleware platform, they're able to connect both the old and the new systems. People who are from the Gulf countries may not see this because most of your projects are all greenfield projects. But when you are putting a greenfield and a brownfield, and how do you have the greenfield and the brownfield systems talk to each other, is the name of the game what Deutsche Bahn has achieved. So with that, they have almost 23% improvement, 35% reduction, and 18% better asset utilization. With that, we come to the homegrown thing. I mean, in AI powered analytics in our Mumbai railway station. So they are using this Mumbai railway station. They are using is a lifeline. Obviously, we know. So the Mumbai Rail Vikas Corporation usually initially used to do a manual counting methods to use the normal CCTV cameras, but now it was very difficult, obviously, because of human inaccuracy. The human counting is prone to error, and also this very labor intensive, and what we call is a video fatigue. Video fatigue means, I mean, anyone cannot simply go ahead and see this thing just because he is sitting in front of the camera. So there's a lot of fatigue for even the normal operators when they see multiple cameras for days together. Or so that way, what has happened is the MRVC has now been able to, with a local company, Indian company, they're able to introduce an AI-driven video analytics system. So by utilizing the existing CCTV footage, the solution, what has happened is the passenger counting. Obviously, with the passenger counting, you can plan your infrastructure, where to put a platform, where should you put an escalator, where should you put an elevator, or obviously you can plan your expansion of the platform or widen the platform with real data. Similarly, even at the peak hour, when the office hours peak hour during going or during coming, maybe from 7:30 to or 7 o'clock to 9:30, 10 o'clock, and even in the evenings. So smarter train scheduling is possible because you can now do a peak hour data and then peak hour density analysis. Similarly, dual time analysis, you know exactly where is the overcrowded zone, so you can optimize the signage. Obviously, you can put the hotspots out there where passengers linger, and obviously, you know where to put what should be done. You can also get into a lot of movement heat maps, so which helps in the placement of where should you do a footbridge, where should you do. These are all initially traditionally being done manually and gut feeling, but now you have a lots of data to do that. So even we see same thing is being done from London King's Station, Tokyo SMRT. Similarly, we have the AI in safety and security. I mean, today nowadays we are using lots of so lots of camera and video analytics for the rail crossings. Obviously, we know that rail crossings, US data says 900 injuries, 250 deaths annually, but India it's far more. So the crossings remain one of the deadliest points in railway network. So what many of the Japanese and the Europeans, what they are doing is now they are using lots of video analytics and using the CCTV adoption, but as I said in the Mumbai case, the video fatigue or the video blindness can prevent you from actually doing that. So now that they are using AI powered video analytics, so the video analytics, you train the models on different videos of the system. So they are AI systems. Obviously, all of us know they excel on repetitive monitoring of video streams and all the stuff, and they're able to do a huge amount of reduction in this particular this thing. I am not getting into too much of a detail because then this slides itself will take a lot of time. And interestingly, many of you know, I mean, we had a very unfortunate accident day before yesterday in the northeast of railways where yeah, 8 elephants were killed. So now, elephant intrusion detection in many places have, particularly in Assam, they have put up, but it's still in a POC mode, proof of concept mode, where they're using CCTV along with a edge object detector and thermal IR cameras for low side, and they're able to do a distributed acoustic sensing on a fiber. so that any elephant crossing they know before, and they are able to inform the driver in much in I would say far more ahead. This is the network rail thing, where in network rail, the what the computer vision, what they are doing is that they are monitoring the level crossing, the trespassing prevention, even intrusion detection. Also, they are doing this particular thing, and they're able to do obviously there were the implementation challenges, but they're able to do lots of other things, and they're able to bring down the. So obviously, coming back. The AI projects require deliberate planning, cross-functional buy-in, because unless the whole ecosystem buys in, it's difficult. And as we said, quality data is a major, I would say, the necessity, basic necessity, foundational necessity to do that. And successful AI deployments obviously still hinge on the regular support of the leadership, because otherwise you can't do anything. And the most sophisticated AI, as I always say, is worthless if it doesn't solve real business problems. So that way, we need to have the right data, because it's garbage in, garbage out. So unless you have a good data, it is difficult. So these are some of the challenges you have, and obviously, there's a I would say a barrier analysis. What do I mean by barrier analysis? Because we say that AI can be doing this, we can say AI can do this and all the stuff, but what happens is that there is a huge resistance within the team. Wherever you are putting this, many people feel that they will lose their jobs. So that way, there's a huge resistance. We How the senior management deals with that is what matters, because the situation is coming very soon where AI would be your teammate. There is no place where AI will be replacing you. It will be that you have to work. Instead of having five workers, maybe one or two would be human. Rest balance would be either an AI agent or a cobot, or some sort of an AI system, which will tell the two human people what to do, what not to do, and try to make them more. They will focus on the more of the insights, while the grunt work, while the routine work, and the I would say the huge calculations and the pattern analysis and all those stuff would be done by the AI teammate, if I may say. So some of the questions what most of the people have to ask is something like this, and with this, these are the usual metrics: the MTBF, the MTTR, the inventory terms. These are all being monitored after and before the AI applications. And this is a case I would not be able to mention the EU railway company, because this is I mean, because of the other issues. But what I wanted to show you, this is a real-time case where the illustrative revenue was almost like a 5 billion euro sort of a thing. The operation cost, rolling stock, infrastructure, and with that, I mean, this is a case study from the McKinsey. You can see that they have also not, but we know the which is the company. Many of the people out here are from that same company. They have done a massive good work of implementing AI, and with that, what has happened is they're able to save almost 0.25. This, if you see, and they are able to save almost 700 million euros per year, which is a significant saving. If you have a 1.1 billion as profit, and if you add a zero point 0.7, so you have a 1.8 billion as profits. So you understand how powerful is this implementation. With that, I have finished my presentation. Let's have, I mean, these are some of the future vision which is happening. Like, for example, the intelligent railway ecosystem is coming up, where the convergent intelligence is coming up, because what is happening is that with the convergent intelligence, we are able to understand what is happening. The railways are evolving from, I would say, um, isolated transportation systems to more integrated components of maybe a smart city ecosystem, with AI orchestrating seamless mobility experiences across multiple transportation mode, which is almost like the mass or the mobility as a service, which is available as an app by a mobility aggregator, just like you have the Ola as a taxi cab hailing aggregator or Uber. So there you have a mass as a mobility services as a service aggregator who helps you to plan your journey using multiple modes, be it a cycle, e-rickshaw, or sorry, not e-rickshaw, e-scooters, and similarly bus, train, regional trains, S-Bahn, U-Bahn, you name it, everything can be done. It is being done in Germany, many places in Europe. Similarly, the increase in railway ecosystem would be very highly predictive, that will anticipate the passenger needs, predict and prevent operational issues, and are able to optimize the performance before any such problems happen, which as we saw. And obviously, sustainability is the optimization reduces lots of energy consumption, minimizing environmental impact, and it supports global sustainability goals also. With that, I have come to the end of my presentation. So let's see what questions you have.
Thank you, Dipankar sir, for this wonderful presentation. Participants, many of you would have actually thought that we co- we tried covering too much of content, but we tried our best to give you an extensive coverage of rail AI applications. And we feel that we understand that AI application cannot be covered in 2 hours, specifically in the railway context. And that is one reason we have been trying to work out an extensive program about which I'll talk later. Let me take up some questions from you, and I can see some praises flying up. If you really like the presentation by Deepankar sir, please type in wow in the chat box. The praises from the participants are very thank you, Bellam, thank you so much, are very encouraging for us to come up with these kind of masterclasses. Thank you, Arun, thank you, Shivangi, thank you so much. Manjunath, thank you. Biru Singh, thank you. Pathuri Narendra, thank you so much. Muhammad, thank you very much. So let's take up some questions now. So Chaitanya, Chaitanya would like to know more about the program in AI in railways in collaboration with IITM Pravartak. So I'm putting in the link of this particular program in the chat box. I would request you, those of you who would like to understand more about the program, please, you could explore this you could visit the program. It has all the details. You could go through the curriculum. You could go through the kind of topics that we are trying to cover. So there are close to about 30 plus topics uh, of 3 hours each. So you could check that up. Now going to the next question.
Let us take the question of Mr. Ali Usman. If you
Ali
are there, Ali
Usman,
Usman,
Ali Usman. Follow
he
an
talks
order,
about.
sir, so that I don't miss the
Okay,
questions.
okay. So
So let
these are the questions which came at the earlier stage. Okay, well, go ahead, no problem.
okay.
Or maybe let me, while
Sophie.
you do that, let me quickly answer Ali Usman since I have read his question. So he's
Okay.
talking about how AI can improve traction motors and gearbox life, what type of IoT sensors we can use, what type of data we can collect here in Saudi Arabia. We are doing oil analysis, but what more we can do. See, it all depends upon what sort of a data. Firstly, the traction motors, you can capture the temperature, you can capture the vibration, you can capture the current, and once you are able to capture from all the four traction motors or two traction motors, whichever is your bogie configuration, and you can cross validate it and try to find out if there is any fault or not, and with the past data you will be able to get a significant amount of idea about if there is any failure possibility or not. And IoT sensors are, it depends upon what sort of a system you're using. You can buy any of the standard available IoT sensors, and in case if you need some sort of a help in that, you can also talk to Sumit. We will be happy to get deeper into it and give you how I mean we can have sensors which are agnostic to any of the systems, so that you are not bounded by any particular system.
Okay.
Yes, Sumit, go ahead.
We could take a question from Jaideep Pawar also. So his question is: have your cybersecurity software OEMs able to beat the resistance to change by operating department who raise the bogey of OT security uh, and thought the decisions to spend on cybersecurity or automation like CTC, citing an unnecessary spend when manual operations is cost effective? So, sir, is the question clear to you?
Yeah, the question is clear, but nowadays it is very simple, Mr. Power, that all the so-called specifications of the railways are coming with cybersecurity. So you have no other choice but to not to do it. And many of the subsystem, even if you have the operating department not liking it or not, but all the new trains they have the cybersecurity hardware there. And the fact that I mean, we saw during the particularly in India during the Operation Sindhu, there were more than 5 to 6,000 cybersecurity attacks on many of our systems, starting from a state bank to a LIC and everywhere. So there's no other way that our railways, be it metros, be it the regional trains, can save themselves. So I mean, this debate is there, but again, it's a question of leadership to push through to implementation of the cybersecurity things.
Okay, thank you. Thank you, Dipankar sir. Victor Etuk is asking for a system in Nigeria where train dispatching process and track management maintenance system is purely manual. How can AI be infused into the system to drive optimization?
For that we have to put in collect the data, sensorize the whole system, and from there you have to put it's a long drawn thing. It's not that we can do it tomorrow just putting in sensors. We have to plan what to optimize, what is required, and then we can select maybe a particular fleet, and also maybe a particular route and a certain portion of the route, and we do the sensorization, we collect the data, use standard algorithms to come out with dashboards, where these dashboards, depending upon what sort of a need Nigerian railway managers will have, we, all this thing can be done, but it has to be done from scratch.
Okay, so there's a very interesting question from Arun Singh. So he's asking from cybersecurity POV, securely share data from a control domain to an OEM or vendor for informed decision making and AI use cases. So, how you see sharing of data from a cybersecurity perspective as a challenge in AI digital transformation?
See, the basics is something different. We are not sharing data which can be of import, or which can be anything. I mean, something can go wrong and the system can be put in this thing. One. Second is there is something called a anonymization of data. For example, if my personal data that I come to this particular station every day morning 7:30, I will not be sharing that data. That data would be anonymized by the system, by the software, before it passes on. So that way these layers of security are already built in. One. Second, in the cybersecurity space, you obviously you have your own cybersecurity algorithms and all already there, which takes care of the different type of phishing on different type of other attacks.
Okay,
So
thank you, sir.
yeah.
So there's a question again from Victor. He's asking, I work as a senior traffic officer with Lagos Red Line. I would like to know how to utilize AI to ensure operational safety to optimize line capacity in train management system.
Come again. I just missed it. You come again.
Uh, Victor is working as a senior traffic officer with Lagos Red Line Metro Railway. He would like to know how to utilize AI to ensure operational safety to optimize line capacity in train management system.
Yes, I mean these are all. If you see this train management system, optimizing train scheduling, route optimization, these are very standard softwares now. These are standard applications are there. Whether if the question is you want to buy it from the typical OEMs like the Siemens and the Alstom and other people, or in Nigeria you have to have a drive where you want to develop, get hold of some of the IT majors and develop this system. It is possible, since and if it is a choice versus the cost. If the cost and the time is exorbitant by developing it separately, then you have to think of implementing systems which are already there to optimize different trains, different fleets, from the OEMs of the trains, the signaling software people. They all have these systems. What we have been talking now is the basics of the system, how the systems operate. If you have to get this system done, you have two choices: either you have to build it scratch by scratch by using your people from Nigeria and some software systems companies who does this sort of a work, and do the hand holding for and the skill development for the people from Nigerian Railways. Or you can buy it from the Ansel Brida, the Hitachis, or the Alstom or the Siemens of the world.
Thank you, Deepankar. Sheikh Mohammed, uh, I'd like to understand how AI can support railway track and assess maintenance. Sheikh, we have a detailed program which covers the track maintenance and asset maintenance through predictive and analytics and condition monitoring. So I would request you to please check out our program on this particular topic, which covers all these topics: how current data ingestion happens, how to data visualization happens with Power BI, how deep learning happens in railway domain, how various integration of AI technologies happen in rail operations. So this will help you or give you a very good idea about detailed working of AI application in railways, specifically to tracks and asset maintenance as well. Uh, Mustafa Shokri is asking for the interface and integration activities. Are there modules or application that might support the process from creation, definition, and tracking for a matrix and the register?
Can you repeat the question?
For the interface and integration activities, are there modules or applications which are there that might support the process from creation, definition, and track for the matrix and register? Mustafa, would you like to rephrase your question if you're there? I can let me see if Mustafa is there. Mustafa, yeah,
The
Mustafa,
whole
I can.
idea is whole
Yeah,
idea is that, I mean, you can do everything. It depends upon the time and the cost. First point.
Mustafa.
Second point is that what are the things already there. I mean, this has to be planned properly. It's not a one point answer that can be given.
Mustafa, I could unmute you if you would like to ask your question. You could do that, or type in your question again in the chat box. I'll take that up. Okay, Ali Usman, do you have any course on wheel? Yes, we have wheels parameters, tolerances, and effective track. Yes, we have track and track and wheel interactions. Uh, Okay. Please send us a mail. I will ask somebody to contact you, Ali Usman. If Jai is here, Jai, please note down Ali Usman's request. Please send him the requisite details. Yes, Mohammed Khamis, we will share. My team will contact you and share the details. Now, so far he is asking, is it we still utilize SCADA systems to acquire all the historical data for analysis, right? For in the railway context, sir, Deepankar, sir.
Yeah,
So, do we still utilize SCADA system to acquire all
yes,
the historical data?
you see, SCADA system is anyway used now. Whatever telemetry, whatever data we are using, actually it's a type of a SCADA system. I mean, in the sense, this all the sensor ecosystem, what we saw in the train and in the wayside, and also this, and the data is being transferred to the data aggregator hub into a telemetry sort of a thing using a 5G or a 4G or a GSMR. This is actually the basics of a SCADA system. So that way, SCADA system is there, but the SCADA system has now been, I would say, augmented with many of the different sensor systems and the output of the SCADA system is also now being worked upon by different machine learning algorithms to give a much more deeper insight. So the overall basics of SCADA system is still there, and it will be there.
Okay, so with this note, I think we've completed all the questions. Now, I would like to share one particular thing that those of you who are looking at a certificate of attendance, so we have put this masterclass as onto our website, which you can actually attend. And if you're able to, you'll be able to qualify a quiz that we have set up for this program. You can get a certificate from Railway Academy. So I've put the link of this free course program based upon this masterclass in the chat box. You could click and enroll or register for this. We'll be happy to share more details about this. So whatever is being covered in this session is would be available to you, and you could complete that sessions, attempt a quiz, and get a certificate as well. So for people who are looking at a certificate of attendance, we could provide that as well. So please enroll. I put in the link in the chat box. You can enroll into this course program and get a certificate from us after you complete and qualify the assessment. So with this note, sir, I would like to thank Dipankar sir. And okay, Mustafa would like to say something. Let me just unmute him. Let me just see if Mustafa will like to share something. Okay. Uh, Mustafa. Yeah. Yes. Yes, Mustafa. Please unmute and speak. Share your question.
Yes, my question was for the interface and integration. What I figure out is only by Siemens to cooperate the AI with some platforms like Equinix just to present the dashboard and KPIs. But my question is related to creation. For sure, we have to provide some criteria to the AI to create, but is there any application create the metrics and register for the interface or to maintain the VMV cycle as integration? This is my question.
I mean, this particular question, I mean, I would say there is no given thing. There are two choices. One, if you develop from scratch, then obviously all those things can be developed. But if you want it as a package, then you have to, in Saudi Arabia, you have this, as I said, the Siemens Rail Agent. Similarly, you have the CAF Lead Mine or the Alstom Health Hub. These are systems which are already taking up the data from different sensors, different subsystems, and they are able to create a dashboard where you can see the condition of the different subsystems. You can do a planning of different maintenance strategies of those subsystems, and obviously you can take lots of decisions. So these are all already available in the market. While if you want to do it from scratch, then we have to go to the basics, like whatever sensor ecosystem is there in each of the trains or each of the fleets. Obviously they would have the data aggregation out there. For each of those data aggregation, you have nowadays, you have the rail suits available. Rail suit means software suits available, which actually will pull those data and create. You can define, create, and design your own dashboards for those sort of a data, so that whichever data you feel is important, obviously the software or the rail suit guy will sit and handhold the railway operators about what can be important and what can be required to give you an actionable insight into what you should be doing, and which data is important, and which sensor is important and which is not important. All those things can be done.
Okay, I think Mustafa, does that resolve your question? Yeah, thank you, Mustafa. Thank you. Uh, yes. So you need to just go here, click on enroll, and complete the enrollment with the details and everything, and you could and our team will be sharing the details of course access with you in next 24 hours, and then you could attempt that. So with this note, so there is no charge that we put in. You just have to proceed with checkout, complete your details, and you will be able to purchase the course program. So with this note, I would like to thank Dipankar Ghosh for this uh, presentation, and we hope that this 2-hour masterclass would have given you ample insights to consider your career growth in AI applications in railways. And if you wish to learn more, please check out our detailed certificate programs. We look forward to seeing you in the class. So with this note, thank you and have a great evening ahead. Thank you so much, sir. Thank you. Thank you very much, Deepankar, sir. Are you there, sir?
Yes, sorry,
Yeah. Okay.
1 minute. I'm there.
Okay.
Oh,
Thank you so much, sir. We are concluding the session now. Thank you very
yeah.
much. Thank you.
Thank you. Thank you.
Thank you.